All right, everybody, let's get down to simplifying rational exponents with a numerical base. So your last video was a variable base. I'm going to tell you right now that numerical bases are much trickier to work with than a variable base. And they follow the same rules, but when you're working with numbers, things can be different. Let's just put it that way. So let's just check it out. Same rules apply when we're talking about exponent rules. When you multiply, you add exponents if they have the same base. If they don't have the same base, they have to have the same exponent. So an example, this guy right here, they have different bases and different exponents. You can't do anything. It's done. But there is something you should always check first. In this example, it's not going to be able to be simplified anymore. But I'm going to teach you a really awesome trick. Whenever a number itself can be simplified, do it. So 4 is actually 2 squared to the third power. And when we raise an exponent to another exponent, we know we multiply. So this is actually 2 to the 6th times 3 squared. It can't be done. And yes, of course, we can say 2 to the 6th is 64 times 9, and we can multiply that and we can get numbers. But the purpose of this video right now is to show you how to simplify. So whenever possible, try to get things down to the smallest base. This one, same base, so we can add our exponents. That's just 2 to the 7th power, no big deal. This next one, different bases, but the same exponent. We can multiply those. 3 times 4 is 12, so we can call that 12 squared. So yes, you could type in the calculator. You can do 16 times 9 and get your 144 and all that kind of stuff. But we don't want to right now. We're just working on simplifying for this video, okay? Let's go to this next row. Now what I'm going to try to do in this video is take different approaches to different questions, just so you can kind of see what might happen if you do things a certain way. So 4 to the 2/3 question. What if you don't change that to 2 squared, which would give you 2 to the 4/3? No worries. Let's do it. This would become the cube root of 4 squared, which is the cube root of 16. And then you would just break it down with your factor tree. You'd have 4 2's. You would circle a group of 3. So you'd have a 2 on the outside, left with the cube root of 2. So when you're simplifying, it'll still work out. It might just be a little bit different. For this problem, I'll show you 2 different ways, just for fun. What if you switched that and you changed that to the smallest base, like I recommended earlier? So that would be 2 squared raised to the 2/3 power. So what if we were to just start with 2 to the 4/3 and then write that as the cube root of 2 to the 4th. Then 3 goes into 4 once with a remainder of 1, just like we were simplifying with variables in the last video. So that's why I wanted to show you there's different ways of doing these. As long as you're getting the correct answer, it doesn't matter which approach you want to take. Okay? Remember, negative exponents are reciprocals. Again, you could change that to 2 cubed, and then you would just have 2 to the negative 1, which would just be 1/2. But let's pretend you didn't recognize that. The first thing you should do is take the reciprocal, so that's 1 over 8 to the 1/3 power. And then we would write that as the cube root, or if you're slick enough by now, we know that the cube root of 8, 8 to the 1/3 is 1/2. Okay? So at some point, you're going to have to start becoming very comfortable with different types of roots. The cube root is also 1/3 power, so it should be pretty easy for you to recognize that 8 to the 1/3 is 2. You should not have to rewrite it as a radical. But if you do, it's fine. So example right here. We can't simplify a 6, So this is just 1 over 6 to the 1/2 power, which is 1 over the square root of 6. You can't have the square root of 6 in the denominator, so you're going to have to rationalize it. Since this is a square root, you only need one more, so you're going to end up with the square root of 6 over 6, and you are done. There's nothing else you can do with it. Okay? Now we're going to step up in difficulty just a little bit, and we're going to work with dividing. So remember, dividing is subtracting exponents. And multiplying, still adding, but we have fractions now. It's okay. Same base. Add our exponents. 3/4 plus 5/4 is 8/4. So that's 2 to the 8/4. 8/4 is 2. So that's 2 squared. So our answer is 4. Done. And yes, sometimes you could check those with your graphing calculator. If it doesn't work out to be a radical, it'll work. If you type 2 to the 3/4 times 2 to the 5/4 in your calculator, it'll give you 4. If you type 8 to the negative 1/3, it'll give you 0.5. So your calculator can check these for you. Next example, 16 to the 1/3 power. You could change that to the cube root of 16 and break it down with a factor tree, but this time I'm going to show you the other way. Write it as 2 to the 4th power raised to the 1/3. So that's 2 to the 4/3 power. So that is the cube root of 2 to the 4th. And 3 goes into 4 once with a remainder of 1. So we have 2 cube roots of 2. Now, like I said, you could have just taken the cube root of 16 if you wanted to and broken it down with a factor tree. It's really up to you. When you divide, you subtract. So 4/5 minus 2/5 is going to give you 3 to the 2/5 power. And that's going to give you the 5th root of 3 squared. And that cannot be simplified, so you just have the 5th root of 9. Done. Okay? So those are all the basics. Let's go throw it at some challenge questions. So these might not look that much more difficult. Really, it depends on the approach you take. So you could easily see that you can't do anything with that yet. They need to have the same exponent or the same base. But you could change 16 to 4 squared to the 1/3. So now you do have the same base. You have 4 to the 1/4 times 4 to the 2/3. So when you multiply, of course, you add your exponents. So 1/4 plus 2/3 is going to be 11/12. So that's 4 to the 11/12. So then you decide that you're going to take the 12th root of 4 to the 11th, and 12 doesn't go into 11, and now all of a sudden you think you're done. That's where you're wrong. 4 needs to be changed to 2 squared. So that's actually the 12th root of 2 squared to the 11th would be 2 to the 22nd. So that's why I was telling you, you should always try to go to the simplest base from the beginning. This one you should have gotten bases of 2 for both, but I just wanted to show you what would happen if you didn't. The problem can still be done. So 4 is actually 2 squared. So 2 squared to the 1/4 would be 2 to the 1/2. And then 16 is 2 to the 4th raised to the 1/3, which is 2 to the 4/3. And then right off the bat, that would get us all the way down to what we need to be, and that would give us 2 to the 11/12. So then you would just take the 12th root of 2 to the 11th, and you'd be good to go. So obviously, this one is not really done. We could simplify this here. So how do we simplify? What we need to do is change that. 12 goes into 22 once, so we take out a 2. We have 10 left, so 12th root of 2 to the 10th. And now look, that would be like 2 to the 10/12. So it's actually 2 6th root of 2 to the 5th. So again, things are getting a little crazy here. That's just a tricky problem. You got to work with it. Next one's actually very simple because they all have the same exponent. 6 times 4 is 24 divided by 3 is 8. So that's just 8 to the 2/3 power. Since they all have the same exponent, the exponent will not change. So then 8 to the 2/3 power, again, you can do it multiple ways. I would change that to 2 cubed to the 2/3. So then that's going to give us 2 to the 6/3, which we know is just 2 squared. So the answer to that guy is 4. That whole thing simplifies to 4. But the next one can be done, but looks like it can't. Here's why. 8 is 2 cubed. 4 is 2 squared. So this can be simplified. They all have a base of 2. So 2 cubed to the 2/3 is 2 to the 6/3, which is 2 squared, times 4 is 2 squared, and 2 squared to the 3/4 is 2 to the 6/4, which is 2 to the 3/2, all over 2 to the 1/2. When you multiply, you add your exponents, so 3/2 plus 2 is 7/2, so that's 2 to the 7/2 over 2 to the 1/2. Subtract because you're dividing. 7/2 minus 1/2 is 6/2, which is 3. So that's equal to 2 cubed, which of course is 8. Lots of crazy stuff going on. I'm aware of that. However, just got to know how to work with it and you'll be good to go. Again, the nice thing with numbers is a lot of times you can just check it with your graphing calculator. All right, that's it for this guy. This is Longo and I'm out. See you, bye.